Hello, and thank you for taking time out of your busy schedule to join us today. My name is Dr. David Bleiweiss, Chief Medical Officer for Cell Science Systems. The purpose of this webinar series is to broaden your understanding of the immunological differences between innate and specific immunity and how those differences manifest in disorders ranging from gluten and other food sensitivities to more severe manifestations such as celiac disease. In the upcoming lecture titled The Leading Edge of Functional Neurology, board-certified neurologist Dr. David Perlmutter will discuss the critical gut-brain connection and the role that gluten plays in the development of chronic neurologic degenerative diseases. Be sure to stick around at the end of the lecture, as I'll be giving you information on some of Cell Science Systems' innovative laboratory testing. In this, his first lecture, The Leading Edge of Neurology, Dr. David Perlmutter explains how we can positively impact the increasing epidemic of chronic neurological disease through lifestyle, which not only induces changes in our physiology, but in our DNA epigenetics as well. We learn that prevention of oxidative damage to our brain, and hence the mitochondrial failure causing neuronal death, ultimately resulting in brain dysfunction, is not available through prescription drugs, but simply by what we eat and how much we move. Sit back and relax. You're going to enjoy this. And now, Dr. David Perlmutter.
I'm very excited to be here, and let's move ahead. I'm not sure what that is. It's the time of the season when love runs high. In this time, give it to me easy. Who knows who that is? Who? Microglia. All right, here we go. We live in a very challenging time indeed. We heard some statistics earlier about the money spent on cardiovascular disease and in cancer, but the reality of the situation is that brain disease is by leaps and bounds leading the pack, and it's scary business. This is a report that came out of England looking at why people are dying, and the study went from 1979 to 2010 and looked at the rates of death from neurologic diseases in the top most populous Western countries. And what was found really quite interesting is in going from 1979, the reference year, to 2010, deaths from neurologic disease in the United States increased 66% in men and 92% in women, by far and away exceeding in any of the other Western countries. So we're number one. Genetically, are we different from our European brethren? No, we're not. So this is all about lifestyle. It's all about inducing changes not only in our physiology, but inducing changes in the expression of our DNA epigenetics. The empowering part of that statement is we can make changes. And we as physicians, i.e. teachers, really are called upon to look at the big picture in terms of what we can be doing to get away from this statistic. By far and away, the biggest issues are directly related to lifestyle approaches, changes. And you may be surprised to learn that Alzheimer's disease is absolutely dramatically related to lifestyle choices. The purpose of this conference, of course, dealing with nutrition, and what we're going to explore now that I've had the opportunity to add some more material, is what are those lifestyle choices that relate to Alzheimer's disease and other neurological problems, and what can we do to learn about them and gain a fundamental understanding of them, and then ultimately translate that material not only to what we do with our one-to-one encounters with our patients, but on a bigger scale, what we do through social media, what we do to get the word out. This is in sharp contrast to the major other causes of disease, which actually improved somewhat during the decade. Cardiovascular disease and some form of cancers actually declined in their incidence. But brain disease, and specifically Alzheimer's disease, is rampant. This is an article published recently, several months ago, in the New England Journal of Medicine, and it's the results of a RAND evaluation that looked at the cost of dementia in the United States. They found that the prevalence of dementia in the population age 70 years or older is 14.7%, and it costs about $41,000 to $56,000 a year, but in the country, around $200 billion a year spent taking care of people who have a disease that is by and large preventable. Now let me put these in perspective. The RAND report at least told us that this is an amount up to twice as much as we spend on coronary artery disease and almost triple what is spent on treating cancer patients. And the point is that we fully know what is going on with Alzheimer's disease. Alzheimer's is not Aricept deficiency, as you may have been led to believe. Alzheimer's, like any neurodegenerative condition, is predicated on the action of two fundamental players. And what are they? They're inflammation and free radical-mediated stress. And these two concepts are intimately related, and we're going to explore that at great depth. But in reality, we have absolutely the opportunity to choose the brain on the left or the brain on the right. This isn't written in stone. I did a Huffington Post a couple of weeks ago talking about a new publication in the New England Journal of Medicine showing yet another failure of an Alzheimer's drug that was designed to reduce beta amyloid. And that kind of flying in the face of our knowledge that Alzheimer's is significantly preventable. So let's look at Alzheimer's, and if any of you were at the Institute for Functional Medicine conference in Dallas a couple months ago, I'm taking some of this information from there. The brain's macrophage system, in the brain we call them the microglial cells, somehow become activated. They secrete the mediators of inflammation that we call cytokines, which directly leads to the upregulation of oxidative stress, the production of radicals. Ultimately, the very same players, the very same parts within the cell, the mitochondria, that make energy, make the free radicals, and suffer the most damage from oxidative stress. You know, mitochondrial DNA, for example, is very, very susceptible to damage from oxidative stress because it lacks, for example, the histone repair mechanisms that nuclear DNA has, for one reason. But when the mitochondria fail, when your energy organelles begin to fail, ultimately that leads to neuronal death. Mitochondria actually induce apoptosis, and ultimately that neuronal death, at least in the Alzheimer's patient initially, takes place in those cells that are cholinergic, the so-called cholinergic hypothesis. Understanding that cholinergic hypothesis was looked upon as being the cornerstone of Alzheimer's, pharmaceutical companies latched on this and created drugs to increase acetylcholine. We call those cholinesterase inhibitors, and look where they work. If you look at the continuum, these are designed to act here with complete ignorance, do I say, a complete avoidance of considering the cause of the problem, treating the fire, not just focusing on the smoke. We're focusing on the smoke here. The cells are already dead, right? The cow has left, the cow has not only left the barn, the cow is here in LA making Chick-fil-A commercials or something along those lines. So the cow is way out of the barn. But we've got to take things back and look at things in a preemptive way, because we've got some very, very powerful leverage points here to keep the barn door closed. You know, John Kennedy said that the time to fix the roof is when the sun is shining. The rain's coming in here. This is when the sun is shining. Inflammatory cytokines, the brain is just on fire, and it's our mission to put that fire out way before we get into a feed-forward cascade, ultimately leading to mitochondrial dysfunction, leading the way to apoptosis, pre-programmed cell death, and neuronal loss. And it's similar to understand that this is a mechanism also in Parkinson's disease. And where do we focus? We, in quotes, focus on this decreased dopamine in the brains of Parkinson's patients. And, in reality, we tend to neglect all of these other factors. We're going to explore these in Parkinson's a little bit later. And once again, dopamine and dopamine agonists, treating the smoke and ignoring the fire. So I want to focus in on this continuum and look at what we call our leverage points. Look where we can work today to actually be preemptive when it comes to neurodegenerative conditions. Who knew? I mean, who would realize that these conditions can be prevented? People go to the doctor, cognitively impaired, one taco short of a combo platter, and say, give me something. And there's nothing to give. If there was something to give, I'd be writing prescriptions for that medicine. Believe me, I would. But there isn't. Let's focus on oxidative stress, mitochondrial failure. Let's get deep inside the brain and realize that what's powering these neurons is energy production at the mitochondrial level. So we've really got to jump into these mitochondria and recognize that these are, thought to represent endosymbiotes. These are what we now call organelles. Were once free-living bacteria having bacterial DNA, circular DNA, much as bacteria do. And really, a DNA that's quite apart from the nuclear DNA where all the interest seems to be. Totally different mitochondrial DNA inherited from mitochondrial Eve. And if you read Science last week, you realize that mitochondrial Adam, who was thought to have come along a long time before mitochondrial Eve, now appears to have been present at this. When you track Y chromosomes, looking at male DNA, and you track mitochondrial DNA, tracking maternal DNA, coming always from the mother, looks like they evolved about the same time. But we've known for a long time that ultimately, or maybe primarily, Alzheimer's disease is a defect of mitochondrial function. It is a defect in the very basics of the electron transport chain. Who knew? This is the first consideration. And this is old news. This is back in 1994. It's a generalized depression of mitochondrial function throughout multiple levels of oxidative phosphorylation throughout the brain, not just in the nucleus basalis of Minert, if you want to get technical about it, or those cholinergic pathways, the tract of Vic d'Azur that I had to learn about when I was 14 at the dinner table, but they still serve me, I guess. But nonetheless, it's a diffuse brain mitochondropathy, to the extent that Dr. M. Flint Beale, who really is one of the monumental players in this understanding, talks about how very important mitochondrial function is in all neurodegenerative conditions. So if you want to have a list of those neurodegenerative conditions that are predicated on mitochondrial dysfunction, the trick, the mnemonic I use is whatever neurodegenerative condition has a vowel in its name is one in which mitochondrial dysfunction is present. Okay, I'll let that one hang in the air for just a moment, because you're thinking, Alzheimer's, there's an A, Parkinson's, there's an A and an I. Anyway, wrote this wonderful book. The cornerstone of these neurodegenerative conditions is energetic, it's mitochondria. Keep in mind that beyond just producing ATPs and all of the steps in oxidative phosphorylation that we all know and love, mitochondria are the harbingers, or rather dictate which cell will live and die, quite simply. The set point of mitochondria energy production in terms of its efficiency dictates whether or not the cell will ever die. The mitochondria wield the sword of Damocles and regulate apoptosis or pre-programmed cell death. Now, everybody's kind of anti-apoptosis because, it means cells are dying, but apoptosis is a fundamental player in human physiology from the moment sperm meets egg. There is a time ontogeny recapitulates phylogeny. If you look at embryogenesis, you see we go through our reptilian stage, where we have limb buds that look like a salamander's. And what causes the differentiation of your 5 fingers is apoptosis between the fingers. Apoptosis is a process by which we hope cancer cells will be dealt with. So it's not all bad. But nonetheless, let's get back to where we were. Morphological, biochemical, genetic mitochondrial abnormalities characterize Alzheimer's. So Alzheimer's is a mitochondropathy. And this study actually is very interesting. They took cells depleted of their mitochondrial DNA, and they put into these cells the mitochondrial DNA from Alzheimer's brain cells. And what did they find? Took out the mitochondrial DNA, and then they took Alzheimer's cells, mitochondrial DNA, and they populated the neuroblastoma cells. And they found that immediately apoptosis was increased, and there was a bioenergetic impairment. The bioenergetic impairment leads to this apoptosis. So, if you don't want your neurons to die, you have to concentrate on bioenergy. on nurturing your mitochondria, giving your mitochondria the fuel that they desperately need, and creating a mitochondrial-friendly environment. Now, what does that look like? We're going to get there, I promise. From the International Journal of Alzheimer's Disease, an article was published, and I summarized the article by making graphics, which is what I normally do, because it just helps me. And we have these, as the article reported in 2009, unknown factors that can affect mitochondrial function, can delete mitochondrial DNA, can mutate mitochondrial DNA, can lead to, therefore, electron transport dysfunction. When mitochondria aren't working well, we get increased free radical, increased reactive oxygen and nitrogen species. So, defective mitochondrial function from who knows why can lead to this vicious circle. The problem with that is, once that happens and we have dysfunctional mitochondria, it leads to the death of cells. Through activation of the transmembrane cytochrome C, we transmit into the cytosol a signal that activates caspase 3, which turns on apoptosis. So this is the connection by which mitochondrial dysfunction from any cause leads to death of neurons. So we really need to get into this. I want you to keep this flow chart in mind for the rest, gosh, until when? Until tomorrow evening? Okay. You'll be thinking about this tonight. It'll be going around in your head. Mitochondrial medicine, neurodegenerative mitochondriopathies, looking for new drugs, increase aerobic metabolism, enhancing mitochondrial biogenesis. What can we do to turn on the growth of mitochondria? I will tell you there's nothing in the PDR in 2013. But the current literature, leading age literature, is telling us we've got to do everything we possibly can to nurture mitochondria, the cornerstone of neurodegenerative conditions. And if you really want to know, the cornerstone of all degenerative conditions of humanity. Mitochondrial perturbations are protean, spelled correctly, in the neurodegenerative diseases. Basically, that mitochondrial medicine thus far has failed to revolutionize the treatment, meaning pharmaceuticals have not done this yet. It's worth noting, however, that two non-pharmaceutical or non-pharmacological interventions that benefit human health, dietary restriction and exercise, increase mitochondrial respiration. Dietary restriction and exercise. Who knew? Neurodegenerative mitochondriopathies. That means that we're going to have to reclassify Parkinson's, Alzheimer's, multiple sclerosis, schizophrenia, depression, ADHD, you name it. We're going to have to reclassify them. We're going to have to get away from this ICD-9 mentality and create something new called the ICD-10. Well, as a matter of fact, the ICD-10 has already been written. As you may know, it'll be out in November of 14, I'm told. I've seen the ICD-10, which you can look at online, and it's very interesting because there's some brand new diagnoses that you may not be familiar with. It's got more than 68,000 disease codes in it. You should take a look at it. There's V91.07XA. Anyone know what that is? Well, I'll tell you. That's a burn due to water skis on fire initial encounter. And you know, the thing is, boys and girls, I am not making this up. And here's the part that is really breathtaking. This is the initial encounter, like she's going to go out there and her skis are going to catch on fire yet again. Here's another one. W5612XA. One, I'm obviously very struck by a sea lion initial encounter. I did not make this up. This is unbelievable. All right. Here's another one. Struck by a duck initial encounter. Well, the pictures obviously are not going to be in the ICD-10, but anyway, you know, we have this notion that we have to create all these unique names for things. And what I'm suggesting to you today is let's take a step back. Instead of, there are lumpers and splitters. Let's look at the big picture in terms of what's best for human physiology and recognize that there are some fundamental concepts here in degenerative disease, and especially degenerative disease of the brain. I mentioned to you that electron transport issues, mitochondrial issues, are a cornerstone in Parkinson's. And here's an interesting study looking at MR spectroscopy in the brains of Parkinson's patients, basically looking at efficiency of mitochondrial function. Dysfunctional mitochondria will cause a lactate peak. And this is Voxel proton MRI spectroscopy, where they're studying some white matter metabolism in the parietal and occipital radiations. And looking at the proton spectroscopy, let me just zoom in on it a bit. And what you notice is that there's this lactate peak that's in the Parkinson's patient that is not present in the control. That lactate peak is a fundamental indicator of mitochondrial dysfunction, inappropriate mitochondrial oxidative or respiration, dramatic increased lactate to N-acetyl aspartate in terms of metabolism. And it wasn't specifically in the pars compacta of the substantia nigra, if that's where you want to focus, or the radiations from the substantia nigra, the dopaminergic radiations to the basal ganglia. This is an area not thought to be primary in Parkinson's. And it turns out it's this way throughout the brain. And it's saying that these are not limited to the substantia nigra. Impairment is thought to result from defect in complex 1 encoded by mitochondrial DNA. The cornerstone of Parkinson's is mitochondrial dysfunction, not Cinemet deficiency or Mirapex or Requip. We aren't, I ask my Parkinson's patients, when I tell them, I say, what are you doing to treat your Parkinson's? And they tell me I take Cinemet, I take Mirapex. And I say, I want you to know that that drug does not treat Parkinson's. And they look they don't show any expression because they have Parkinson's, so they have blank faces. But I know they're thinking, gee whiz, but can't get the eyebrows to go up. But anyhow, but that said, and then they're waiting for the punchline, and I hold it out a little bit longer just to really, play it up. But I say, you're just treating your symptoms. You're not treating the underlying problem. When we target mitochondrial function with all of the things we like to do, CoQ10, alpha-lipoic acid, intravenous glutathione, all of those things to upregulate mitochondrial function, that's targeting the smoke and not just fanning that's targeting the fire, not just dealing with the smoke. And what is so interesting is that this defect in mitochondrial function in Parkinson's patients is found in their fibroblasts anywhere in their body. It's a body-wide systemic problem. It isn't the board question that, well, where's the defect in Parkinson's? You're supposed to say, pars compacta, substantia nigra. But anyhow, this is the focus. Upregulating mitochondrial function is the powerful leverage point that is non-pharmaceutical and can aggressively treat neurodegenerative conditions as well as prevent them. Well, let's take a look. Who wants to see the slide? No, I know you don't want to see the slide, but it's going to be on the quiz. Thank you very much. You must have some sort of issue with anyhow, so this is oxidative phosphorylation, and the point is what we're doing is we're just sending this electron, gets bounced around and ultimately gets transferred at the end. We'll talk about that in just a moment. Then tomorrow I'm going to have a green laser, you'll see. But the point is, where does it get transferred first? To CoQ10. But what is done to induce Parkinson's in primates and rodents is to give them something that will damage step 1 of oxidative phosphorylation, and it does so very handily. MPTP is a synthetic demerol that was made here in Los Angeles, I'm told, in the 80s, and people were shooting this, and within a few days, many of them developed full-blown Parkinson's disease. So, that was bad news, but it allowed neuroscientists the ability to induce Parkinson's in experimental animals and therefore study the disease. How does it work? It's directly toxic to step 1 of oxidative phosphorylation. Rotenone is another toxin that is this thing that is used to induce Parkinson's disease in experimental animals. You've probably never heard of rotenone, probably one of the most common things applied to sheep and cattle throughout the world, but aside from that, it doesn't get much play. But again, as I mentioned, this is a defect that's body-wide. It's in the fibroblasts of Parkinson's disease. So when I see a Parkinson's patient, this isn't a man who is dopamine deficient. Understand that's a bit of a myopic view of this devastating condition. This is a man whose brain is on fire because of dysfunction of oxidative phosphorylation, very specifically with the transfer of electrons from complex 1 to complex 2. When you have that in mind when you're seeing this patient, it tends to open up a lot of possibility in terms of what you can do and feel good in your heart about doing to help this man. It isn't enough to write the script and send him on his way, hope for the best. Parkinson's disease, for example, is far more aggressive in individuals with elevated hemoglobin A1C. When you glycate proteins and upregulate oxidative stress, these patients go down much more quickly. So it's a big picture, and it takes a little more than 15 minutes. So again, CoQ10 is a way to enhance this transfer, enhance complex 1 to complex 2 electron transfer, and wouldn't you know it, that's mitochondrial therapy. And years ago now, a study was published looking at the use of coenzyme Q10 in a variety of neurodegenerative conditions, saying that bioenergetic therapies like CoQ10 may have the potential to affect the course of neurologic diseases in which mitochondrial function is impaired, virtually every neurodegenerative condition you can think of. Here's the study published by Dr. Schultz in the Archives of Neurology, put out by the American Medical Association, showing dramatic improvement, in the Unified Parkinson's Disease Rating Scale. The lower you are on the scale, the more functional you are after 1 year taking what we would consider a relatively high dosage of CoQ10. 48% reduction in the risk of this person's decline by targeting the fire and not just fanning the smoke. Now, some neurologists, when this was published back in 2002, grasped onto this, but they couldn't write it on the prescription pad. You read the article at night, oh, CoQ10, and they get the prescription pad out and something happens. You can't write CoQ10 on the prescription pad. You have to send somebody to a health food store. Now that's an interesting thing, a health food store. That's a store that carries food that has something to do with your health. What a concept. I mean, what are the other stores? But anyhow, several years later, a study came out actually a couple years ago that showed that coenzyme Q10, when administered to individuals, had no effect on their symptoms. And I was getting emails and posts and phone calls saying, you see, we were right. It has no, and again, those two studies are apples and oranges. One is targeting symptoms, and CoQ10 has no effect on symptoms. Why in the world would it? The other is the fire, the long-term consequences of this electron transport deficiency, and it was dramatic. If a company could develop a drug to slow the progression of Parkinson's 48% in a year, if you owned that drug, you'd be retired, I promise you, and living on your own island. And here's what they determined CoQ10 is. It's safe, it's well tolerated, and it reduced the worsening of Parkinson's disease as reflected in the score. Therefore, conclusion, it's premature to recommend it. And this is 11 years ago, drugs that deplete CoQ10. Well, again, let's get back to some basic biochemistry. Nobody loves this stuff, but I think we're only looking at complex 1 to complex 2. And there are some powerful things in our environment that can be related to mitochondrial function. These are this rotenone is developed because it's a mitochondrial toxin. That's how it works to kill bugs. And we're exposed to it. This was just published, Exposure to Pesticides or Solvents and Risk for Parkinson's Disease, a huge meta-analysis published about a couple of months ago, and looked at the exposure to various things in terms of risk. Pesticides, 58% increased risk of Parkinson's. Fungicides, solvents. I mean, we've known this for a long time because many of these things are mitochondrial toxins. And, oh, I might try that. Let's just see. Hold on. Let's see which one of these works. All right, not so much. All right, so these things are mitochondrial toxins, and does being exposed to a mitochondrial toxin increase your risk for Parkinson's disease? You bet it does. This is what the journal Neurology tells us. That's the American Academy of Neurology. And there's something here called mancozeb or something. It increases your risk dramatically. I don't know what this mancozeb is, but look at this. This is something that is actually, I went to Wikipedia and looked up this stuff and read about it. And it's actually something used in the laboratory obviously, to induce Parkinson's in experimental animals. So, you know, you probably have to be in a very high-end research facility with, you know, level 3 security to use this stuff. I mean, look at the risk. Doubles a person's risk for Parkinson's. So anyway, but just the point is those things are out there. You people could never get hold of Manab unless you went to Amazon, and you would see that this stuff is in this stuff that you buy at the garden store. People are putting this stuff on their food. Hear the echo? And that was a poetic pause, pregnant pause. This stuff goes on your food and your flowers in your vegetable garden, and it is one of the most potent neurotoxic chemicals known, which will double a person's risk if they are exposed to Parkinson's, at which point you can go on Amazon and buy your medicines if that were possible. Again, ignored, Henderson. It's unscientific. The evidence is staring us in the face, and the evidence is being brought to us by our most well-respected institutions, that what people are exposed to is having a powerful effect in terms of their risk for diseases that are untreatable. Gregory Bateson from Harvard once said that man is the only animal who will befoul his own nest, a sure sign of madness. So we've got to pay close attention to our mitochondria and talk about what can we do to enhance mitochondrial function. Well, let me go back. Ultimately, you know, you're passing these electrons along and you're producing ATP, but where does the electron go at the end of the day? Who gets that electron? Well, why do we breathe? Let me make it a little easier. We breathe to take in oxygen. Yes, that's the word I was looking for. Okay, and here now we're going to really push the envelope here. What do we exhale? Never mind. All right. So the reason that we breathe is to get oxygen to accept that electron being passed through oxidative phosphorylation, what a name, to accept that electron, and as such, that's the final receptor creating water and CO2. So that said, again, what happens is it goes to oxygen. So one thing you can do if you want to enhance oxidative phosphorylation, enhance mitochondrial function, is use oxygen. And that's why people do things like hyperbaric oxygen. So there are a variety of things that respond wonderfully, and all of these things are ultimately mitochondrial based. Not enough blood supply, not enough oxygen, not enough fuel for the mitochondria to pass their electrons. Carbon monoxide poisoning, you're not delivering oxygen because of the methemoglobin from the carbon monoxide displacing oxygen. It's all about delivering oxygen to the tissues. We use it for patients with stroke because it leads to neovascularization, but also activation of brain-derived neurotrophic factor that turns on the growth of new brain cells and enhances what is called neuroplasticity, the way that neurons connect to each other. Because when you have a stroke, the center, right at Hiroshima, everything's destroyed. Around the outskirts of Hiroshima, there's been horrific damage, but then there's normal brain. But the issue is that these cells here are functional, but they're not functioning. They're around, they're still alive, but they've been dazed. And we can target what's called the ischemic penumbra using hyperbaric oxygen to have a meaningful impact on patients. So we've been doing this for a number of years. This is a wonderful study that just got published in PLOS actually about January of this year. And it was a powerful, powerful study looking at brain metabolism in patients long-term out from strokes, years out from strokes, and doing SPECT scans on them. Now, yellow is what we are looking for. We're looking for yellow indicative of increased perfusion using SPECT. And these are the control individuals that did not get compilation SPECT scans, who did not get hyperbarics, and dramatic increase in those individuals getting hyperbarics. Compare here to here, compare here to here. And again, baseline and then following hyperbarics, dramatic increase if you look at the yellow, just dramatic improvements and clinical improvements as well. significant neurologic improvements in stroke patients, even at chronic late stages, even patients years out. Dr. Neubauer in Florida has a report in the literature of treating an individual 16 years out and showing significant improvement in that individual. The observed clinical improvements imply neuroplasticity can still be activated long after damage onset in various regions. How do we enhance neuroplasticity, the ability of the brain to reroute information? We do so by upregulating mitochondrial activity and specifically, perhaps in this case, by turning on the genes through an epigenetic mechanism to make more brain-derived neurotrophic factor, BDNF. Hyperbarics is one way of doing it. I'm going to show you two more. And this is, again, what chambers look like. This is a young woman who was at summer camp and had a bad viral illness. She had the flu, and thereafter she had a progressive decline in neurological function. Her workup was really negative. She was seen at a major institution. She had a feeding tube placed, and she was sent home being told, that's it. Take your daughter home. It's as good as it gets.
Touch your head up here on the top, like you're brushing your hair.
Very good. Very good.
Is that okay?
Yeah.
If you were her dad and you were going to say very good, it would be pretty darn hard to do, wouldn't it? That's your daughter. So what did we do? This young woman had an acquired mitochondropathy induced by a virus. That's not strange. Lyme disease, for example, produces mitochondrial dysfunction. We acquire mitochondrial dysfunction through exposure to pesticides, through viruses, through Lyme organisms, through chlamydia that exists sort of in their own world. The idea of mitochondropathy, you know, when we were in medical school, we were told there were about 6 mitochondropathies that we had to study, at least for neurology boards, and that was it. You know, Kern-Sayre, progressive external ophthalmoplegia, MELAS syndrome, mitochondrial encephalopathy with lactic acid and stroke, and others. But we acquire mitochondrial dysfunction. What do you think chronic fatigue syndrome really is? These people are walking around mitochondrial dysfunctional. So what did we do? We treated her mitochondria with hyperbaric oxygen and glutathione to upregulate mitochondrial function and to provide wonderful coverage in her brain for free radical production. So she went on to get her bachelor's in biology, and as of last week, she completed a master's program in physical therapy. So she was actually written about in alternative medicine. When all else failed, oxygen breathed life back into one very sick young girl. Mitochondrial therapy. So, you know, the point is when you activate brain-derived neurotrophic factor, that's a powerful intervention. It does 3 things. It protects neurons, and it turns on both neuroplasticity, the way neurons can connect to each other in new ways, which is fundamental for learning, and it also leads to neurogenesis, the growth of new brain cells. I was recently asked, what are the 2 things that you learned in medical school that have since been overturned? And the first thing I learned was that back in medical school, we were told that our genes are locked in a glass case and determine who and what we would become. Remember that? That was it. The one-way street, and nothing could be done to change the language of your DNA. Well, we've since learned that really everything we do, all of our lifestyle choices, the foods we eat, the exercise we get or we don't get, the amount of sleep we get, the amount of stress we experience have a direct role to play on genetic expression. We'll explore that further. And the other thing that was told to us is that we had a finite number of brain cells up till about, and we grew new brain cells till we were about 18 or some magic time. And then at that point, you had whatever the number was, 100 billion brain cells. Remember that? And then every time you drank a beer, you'd lose 20,000 brain cells. And if that were the case, like I'd be up here giving a lecture because I went to college too, but maybe there were other things we did in college that were on the positive side. We won't talk about that. But nonetheless, the point is, that's been overturned as well. And what's so amazing is that those two seemingly disparate concepts are actually fundamental. That epigenetics, the control of our genetic expression under our control, controls the growth of our new brain cells. Now that is an empowering notion. Brain regeneration, neurogenesis, growing back the very brain cells in your hippocampus that you've lost. And this is fairly recent information. It was published in the journal Nature in 1998, and the research was actually submitted to several other scientific publications and rejected because people just couldn't deal with this idea. No, this is not, I'm not making, the laugh sign will go up when it's time to laugh. It's true. That people couldn't embrace the notion that humans could grow new brain cells. It was seen in rodents, it was seen in primates. Dr. Sapolsky had already published his report showing it in primates, but nonetheless, since I have extra time tomorrow, I'll tell you the story real quick. The researchers, Scandinavian researchers who were hot on the trail, along with a Dr. Gage, who was here in the United States, and he's an interesting, this Dr. Gage is an interesting fellow. He's doing a lot of work in this neuroregeneration and neurogenesis area. But his, I believe, grandfather or great-grandfather was a man named Phineas Gage. Now that doesn't ring any bells, but for me, at the dinner table when I was 14, I had to hear about Phineas Gage, who got an iron rod stuck in his brain and who survived for years and years, but had some hippocampal injury and had some memory issues, but nonetheless, anyhow. But what they did was, they were a group of individuals who had squamous cell carcinoma of the face. And to follow squamous cell carcinoma of the face, these individuals were given bromodioxyuridine, a thymidine analog, which is used to show replication of cells. When cells replicate, their DNA replicates, you can image them using bromodioxyuridine, right? So they did this so they could follow their squamous cell carcinomas and see if the tissues around still showed growth of new cells. Well, some of these individuals died who had received bromodioxyuridine. They looked at their brains, specifically in the hippocampus, and they found bromodioxyuridine labeled cells in the dentate granule cell layer of the hippocampus. So proving for the first time, pretty exciting, that the human hippocampus has the ability to repopulate itself with stem cells and ultimately neurons throughout our lifetimes. Throughout our lifetimes. Self-renewal throughout life. And these are, again, cells stained with bromodioxyuridine in the granule cell layer of the dentate gyrus of the hippocampus. Sorry for being so technical, but if you stain these area also with TUJ1, TUJ1 is a marker for neuronal differentiation. It's not just that we grow new stem cells in the hippocampus, but beyond that, they do, in fact, fully differentiate into functional neurons. So what's happening in your brain as you sit here right now is stem cell therapy. And you want to know what can you do to enhance your endogenous stem cell therapy in your hippocampus. And I'm going to tell you that in just a little bit. So this is really exciting information. Looking at a lot of things, we're going to focus just on brain-derived neurotrophic factor, BDNF. I can't read that. What did it say? Just yell it out. 1 hour. Okay, good. We're on a roll here. And here are the medicines that you can prescribe to people to enhance BDNF, enhance production in their bodies, in their brains. Restrict their calories, physical exercise, DHA, and mental exercise. BDNF is a neurotrophin that's critical for protecting neurons, for the process of learning new information, and also to stimulate the growth of new brain cells in the exact area of the brain that degenerates when you have Alzheimer's, the hippocampus. Let's focus on neurogenesis a little bit more aggressively. Here is a powerful epigenetic player that you should take home. The idea that you can turn on the genes to produce BDNF to grow new cells in your hippocampus. Let's look at the data. The effect of physical activity. So we've known, published in these very obscure medical journals, this one's published, I can't read it, the JAMA. I'm not sure where that comes from, but exercise, I'll get back to that one just a little bit. Let me first look at the laboratory studies. These are mice, rats, or I'll say mice, Pixie and Dixie. Rats is sort of negative. These are mice. And these are middle-aged, like me, middle-aged mice versus young mice. And this just shows if you're sedentary, the growth of new dendrites is here, but if you're exercising, TR means treadmill, look at the growth of new dendrites, the arborization, the trees that happens just from being stimulated by BDNF, brought on by exercise. And these are the older mice, my age, there's still hope. And again, a graphic representation of this arborization of these dendrites happening from just getting on, this is the medicine, this is the intervention, treadmill. When you're on the Precor or the elliptical, which is a Precor, that's redundant, or the Stairmaster or running or doing anything aerobic, you're dramatically enhancing BDNF production through the process of epigenetics to increase your brain cell growth. And again, this looks at bromodeoxyuridine staining, new cells in the hippocampus just induced by exercise, even hope for people my age, so they can remember their lectures and their slides. Exercise promotes neurogenesis. And there is no pharmaceutical in the world that comes close to what exercise of the aerobic type can do for your brain. And it works through BDNF. And I actually went to the lab and I was watching, they were doing these neurocognitive testing on the rodents, and I filmed this with my iPhone. So see, they have the animal takes a test before and after. There's a little delay in the laughter. That means people are looking up, right? Finding out what's on the screen. But does it happen in people? You bet it does. The literature suggesting that exercise is good for your memory has been around for a long time. Exercise improves mental functions in adults who are at risk for dementia. Now, there are very few people who are at risk for dementia, right? I mean, if you live to be age 85, that's 50-50. It means half of you, if we all live to be age 85, means either this half of the room or this half of the room are going to end up with dementia. Or maybe it's the person next to you, or maybe it's you. So why do you want this information? So it's not you, because you can do something today to keep that from happening. You can exercise as published in our most well-respected journals. Exercise and cognitive function in older adults at risk. Your risk is 50-50. If you've got a family history like I do, your risk goes up significantly. If you've got a blood sugar right now, as you sit here, of 105, as per the New England Journal of Medicine last week, your risk goes up significantly. If your hemoglobin A1C is 5.6, your risk... Isn't there somebody who says, you may be a redneck, and it keeps going on? You may be a redneck if, well, you're maybe demented if you've got a blood sugar of 105, your fasting insulin might be 10, and you think that's normal. Your A1C is 5.6 to 5.8. That's not good enough. I will show you what hemoglobin A1C will do to your brain. Nonetheless, this is a group, 138 people, mild memory dysfunction, and they got this 24 weeks of exercise, a whopping 142 minutes each week. That's a lot of exercise. You divide it by 7, that's just dedicating 20 minutes of your day to something aerobic. And what did we find in the Journal of the American Medical Association? The control group, in terms of memory function, dramatic decline as opposed to changes in the Alzheimer's disease assessment score, cognition, actual improvement in cognitive function in those individuals who had this powerful double-blinded intervention. Not double-blind, how could it be? They exercised. This is change in the ADS score, intervention group here, improvement. The results of the randomized trial indicate that activity 142 minutes a week leads to objective memory improvement. So it's just getting out and doing 20 minutes of aerobics. What fits your busy schedule better, exercising 1 hour a day or being dead 24 hours a day? We're grateful to Glassbergen, because we actually were able to get one of his cartoons for Grain Brain, our new book. Here's the nurses' study. They did exercise, and they again looked at them. And here's what the take-home message from this JAMA-reported study. Regular exercise, highest level cognitive function, less cognitive decline. The apparent cognitive benefits of greater physical activity were similar in extent to being about 3 years younger in age. Now, we're at an anti-aging conference, and I'm not recommending some product or injection of something for your wrinkles. I am recommending, as a powerful anti-aging therapy, that we tell people they've got to get out and exercise. It's an epigenetic issue targeting genes for BDNF, and there's nothing available. This is one of the most important studies This, and I have to say, and Dr. Fasano's study on zonulin being the gatekeeper for inflammation, cancer, and autoimmune disease are like two of the big pillars in my life for life changers. This is a great study that came out, and Dr. Erickson showed us we know that the hippocampus shrinks in late adulthood, and I'll just tell you a little something about the hippocampus. You can argue about other things, but when it comes to your hippocampus, size does matter. Because you try to use it in any way you can, and you're still not going to perform. Because if it's... We'll move on. Anyway, they got 120 people, 1 year, and they're told, I want you to stretch, or here's a specific aerobic program to engage in. And then they measured 3 things, and this is very important. They measured the volume of their hippocampus, how big is the hippocampus. They measured BDNF levels in the blood, and where the rubber meets the road, they measured memory function. What do you think they found? Really kind of exciting. Exercisers of the aerobic type are depicted in blue. Stretchers are depicted in red. Now, I'm not knocking stretching. Before you do your aerobics, you should stretch. But you've got to do the aerobics. If you just stretch and don't do aerobics, the size of your hippocampus left and right will decline. But if you do the aerobics and target your genes to produce BDNF, your hippocampus will increase in its size, memory function will increase, and your body will have higher levels of BDNF. Aerobic exercise is neuroprotective, BDNF. And starting an exercise regimen later in life is not futile for people like me, either enhancing cognition or even augmenting brain volume. This comes from a very obscure clinic talking about physical exercise as a preventive medicine in neurodegenerative diseases. What a concept. Exercise as a preventive or disease-modifying treatment in dementia. And what they found, they looked at the research, and what they could, the Mayo Clinic, that is we may have heard of the Mayo Clinic. It's a place up north. And this is what they describe, that these data suggest that aerobic exercise is associated with not only reduced risk of cognitive impairment, but it may slow dementing illness. And what they conclude, it's a prescription for lowering cognitive risks and slowing cognitive decline across the age spectrum. The Mayo Clinic is telling us this is a prescription that we should be using. And I wrote about that in Huffington Post. And so, bye-bye. What should we be telling people? No mas with the pastillas. We need to, this is the prescription that we need. This is powerful medicine. Or have more Facebook friends. It's been shown that more Facebook friends, larger brain structure is important anyway. I'm growing Facebook friends. It's a good thing. BDNF, brain-derived neurotrophic factor. Here's another epigenetic player. This is DHA, a specific omega-3. Now, the DHA is this very fluid part of this fatty acid moiety. And, you know, I want to just mention something that, I notice if you push the laser, the slides don't advance. But nonetheless, BDNF is dramatically accentuated as an epigenetic mechanism in the presence of DHA. Now, if you take fish oil, you're going to get prostate cancer within a week, probably, and die. It's true. It was all over the news. Anybody who's involved in nutritional medicine saw that, because that's exactly how you would interpret the study. The difference between the group at risk for prostate, the difference between those having the highest levels of DHA and the lowest levels of DHA was 0.025%. Now, where do people get their DHA? The study had nothing to do with supplements. It had absolutely nothing to do with fish oil or algae-derived DHA. What did it have to do with? A single one-time blood test for various omega-3s following these individuals for a given period of time. The difference in the DHA levels, again, was 0.025%. If you were in the higher group of DHA, again, 0.025%, you had an increased risk for prostate cancer. So the question becomes, most people are not taking DHA supplements. Where do people get DHA? You get it from eating fish, right? And here's how I interpret the study. So the study is a really good marker of risk of eating fish. Understanding that more than 95% of the fish that people eat now in America is farm-raised. So that's how I interpret it. Now, you can spin these things in any way you want, but I thought that that was a huge disservice to the vital importance of people getting plenty of DHA. The structure will be on the quiz, so you need to get the double bonds right. Martha Claire Morris, publishing in the Archives of Neurology, shows us that the risk of developing Alzheimer's disease is dramatically and inversely related to your DHA consumption. DHA is an epigenetic modulator, very, very important. Decreased level plasma DHA, not just Alzheimer's, but is common in all types of cognitive impairment. And DHA is bonded to phosphatidylserine, so you can measure that. And this is probably you may have heard of a small study called the Framingham Heart Study. Perhaps you've heard of that. They looked at risk of Alzheimer's and other forms of dementia based upon DHA in the blood. And what did they find? Those in the highest quartile of DHA in their blood had a 47% risk reduction for a disease process for which there is no treatment. Preventive medicine. Now, this is not an interventional study. No, it's a retrospective study. And I think that that's kind of important because, you know, we didn't do a double-blind test showing that wearing a helmet on your motorcycle reduced your risk of becoming comatose or having a head injury. Who would do such a thing? So looking at things retrospectively, I think, is really meaningful, because in the motorcycle study, they said, okay, let's do something based upon retrospective. We'll have people put on helmets, and lo and behold, less head injuries. Who knew? And again, this is the risk of becoming demented if you have the highest level of DHA in your blood, the risk compared to not having the other three of the quartiles. So where does DHA come from? It comes from fish and fish oils, and also made in a laboratory from microalgae, which is obviously very sustainable. DHA is now thought to represent possibly an essential, I would call it a quasi-essential fatty acid. You know, our ability to manufacture DHA is really fairly limited, affected by so many factors such as low magnesium, etc. You know, I would call this a conditionally essential fatty acid. Dr. Davis was talking this morning, and I thought it was really very interesting about the sudden explosion of human brain size. And because we suddenly began to use, we began to have other oils in our bodies, in our physiology. And specifically, when you understand that DHA has such a powerful role to turn on growth of brain cells, some researchers have thought that this might represent the time when we discovered marine sources of protein rich in DHA. It's also interesting to note that some researchers have felt that there's been, in the past couple of centuries, about a 10% decline in the size of the human brain. Omega-3 actually, as an interventional trial, has been shown to boost memory function in adults who have mild learning issues, so mild memory issues. What does it do? Well, it acts as a powerful anti-inflammatory, stimulating the PPAR gamma pathway, which is, interestingly enough, also playing a role in blood sugar metabolism. That's where some of our diabetic drugs work. It is a COX-2 inhibitor. I mean, we have Celebrex and all these other COX-2 inhibitors, and again, the COX-2 enzyme wasn't put in our physiology so that we could develop drugs to inhibit it. I remember when I was in medical school, they had just discovered the Valium receptor in the brain. I mean, what marketing person at the company was able to make it stick that it was the Valium receptor? But that said, NRF2 activation, we're going to get into that just a little bit later, but just take-home message here is that DHA turns on brain-derived neurotrophic factor, which augments your growth of new brain cells in your memory center. And what else can you do to increase the growth of new brain cells in your memory center? Okay. I think I'm going to go back to slide 1 here anyway. So let's look at what Johns Hopkins tells us about COX-2. This is, you know, inflammation. It's why we have these COX-2 inhibitors. And this is seen in a variety of neurologic problems, including Parkinson's, Lou Gehrig's. What is it, David? 45. Okay, good. I have to time this for tomorrow as well. So this is a look at COX-2 staining in the hippocampus. Ca means Ammon's horn, or cornu in Latin ammon. This is part of the hippocampus. And this is how demented the individuals were at the time of their death. So if somebody were completely bedridden and vegetative, they had a high degree of staining of the COX-2 enzyme in their hippocampus at the time of their death. Individuals in the nursing home where the patients came who were fairly intact from a neurologic perspective had very little COX-2 staining. So there's this direct relationship between degree of cognitive impairment, dementia, and the activity of this COX-2 enzyme, and how interesting it is that there's this relationship between high levels of DHA and reducing COX-2 activity. So DHA plays this pivotal role then in neurogenesis. DHA, the reason it's so important when we were told as children to eat your fish because fish is brain food, it's because DHA from fish is a powerful modulator of your DNA to turn on the growth of new brain cells. So, you know, we talk about the IQ gene. If I had to locate one IQ gene, I would say it's probably the genes that code for the production of BDNF. Well, let's get back to our understanding. Remember the flow sheet of microglial activation turning on inflammation that then turns on oxidative stress. And I want to focus on that just a little bit. Oxidative stress is the cornerstone of neurodegenerative conditions. Oxidative stress that damages our DNA, our RNA, our proteins, our fats. And these are all easily measurable in the laboratory and in your offices. You can get measurements of DNA damage at laboratories, 8-OHDG, 8-hydroxydeoxyguanosine. You can measure serum lipid peroxides, a measurement of oxidative damage to fat, which I think is a very meaningful test when you realize that 60 to 70% of your brain is fat. I wasn't meaning just you, everybody. So your brain is mostly fat. Fat is such a wonderful word, isn't it? Don't we just love that word fat? Don't you just embrace the word fat? Probably not, but I'm hoping that by the time I'm finished that you will. I'm not saying adiposity, I'm saying fat as a wonderful food. But this is something that happens early in mild cognitive impairment, long before you're an Alzheimer's patient and you need assistance with your activities of daily living. When you begin to have your so-called senior moments that you laugh off, that you forget where you put your keys, or you go into a room and say, gee, why did I do that? Or you lose yourself in conversation, forgetful of telephone numbers, which happens now because what do we have to remember? You carry around an iPhone, you don't need to remember virtually anything anymore. So that said, it's good to challenge yourself to remember new information. Try to learn a new language. Learn a musical instrument. Learn to read music. Whatever you do. But don't forget physical exercise. But the point is, this is the early event. This is the harbinger for trouble down the road. These are the storm clouds brewing that don't have to come, it doesn't have to rain. The early event is oxidative damage. Oxidative damage is the early event in pathogenesis of Alzheimer's. And read oxidative damage. Where is it coming from? Mitochondrial dysfunction. And it can serve as a therapeutic target to slow the progression, perhaps even the onset of the disease. Whoa! Published in the American Medical Association Journal Archives, that you could perhaps keep cognitive impairment from happening if you paid attention to oxidative stress. Now, I don't know what mainstream doctors think about reading this stuff because there's no prescription that you can write here. But how do you reduce oxidative stress? Yes, antioxidants are important, but by far and away, the biggest players in oxidative stress have to do with glycation of your proteins, which we will explore, and the induction of inflammation with things like protein sensitivity. Obviously, apropos this conference, gluten. Gluten sensitivity by inducing inflammation. The downstream effect is oxidative stress, the cornerstone of cognitive impairment and brain degeneration. And that's why all this stuff comes together and why it's so darn important. And that's why I'm glad to be here today, to be able to share this. What are they calling for us to do? Better antioxidants. That's after the fact, though. The radicals have already been produced. We've got to keep the fire from starting in the first place rather than call the fire department to go and put the fire out. Better antioxidants and agents used to upregulate our defense mechanisms against oxidation will be required. It's most likely, this is the good part though, to optimize these neuroprotective agents they're going to have to be used in the pre-symptomatic phase of the disease. That's now all of us. Each of you is pre-symptomatic mild cognitive impairment. I don't know which of you is going to get it, but it's pretty darn likely that we will. What we're being told by the American Medical Association in their journal is that we've got to get busy now while we are pre-symptomatic so that we do, in fact, fix the roof while the sun is shining. Well, how do you measure free radical damage to, let's say, fat? Thiobarbiturate acid reduction substances are a way. You can measure these in your office by getting lipid peroxides of the urine or serum. Many of the labs you do this. In fact, I think some of the labs are here. If you measure a person's lipid peroxides in the urine or blood, it tells you immediately how aggressively they are giving oxidative damage to their fat. And again, the brain is mostly fat, so it's a pretty indirect but correlative type of marker. Look at the difference in T-bars in the temporal lobe and the hippocampal area of Alzheimer's versus not. This is a dramatic representation of what I call the brain on fire. The medial temporal lobes in Alzheimer's patients are just getting baked. And it's a feed-forward cycle. Once it starts, it's difficult to intervene. So like we just learned, the time to intervene is in the pre-symptomatic stages of this disease. And I'll explain fully what I mean by a feed-forward cycle in just a moment. That's timing. So the point is that the more this happens, the more neuronal death we get, it stimulates the influx of calcium back into the neuron, which damages the mitochondria. So it becomes a feed-forward cycle. I'll demonstrate this in a little bit. Increased reactive oxygen species made by the mitochondria themselves, when their function is inappropriate or not up to par, they secrete more reactive oxygen species that further damage the mitochondria. That's why it's feed-forward. However you want to get in there. Again, these unknown factors get you into this place of mitochondrial dysfunction. Let's take a look. What are these unknown factors? And giving us some leverage points, maybe you're getting an idea that there's some way that perhaps food has a role to play in affecting mitochondrial function. Well, let's take a look. Excitotoxicity is the energy-linked excitotoxic hypothesis. It tells us, and this has been around for quite some time, that when mitochondrial function is compromised and we have less ATP production, well, this is the normal situation where mitochondria are healthy, and we've established a normal electrochemical gradient between what's inside the cell and what's outside the cell. When that's present, we have magnesium in this channel, N-methyl D-aspartate receptor channel, and everybody's happy. But if you compromise mitochondrial function for any reason, remember what you can buy on Amazon? You can buy mitochondrial toxins on Amazon, powerful mitochondrial toxins at your garden store. If you compromise mitochondrial function for any reason, then glutamate, which is normally an excitatory, probably the most prevalent excitatory neurotransmitter in the brain, then glutamate, when it stimulates this NMDA receptor, actually leads to a loss of the magnesium relaxation and allows calcium to enter into the neuron. And specifically, this calcium is bound to the mitochondria. The mitochondria sacrifice themselves and suck up this calcium. So this NMDA receptor has been looked upon as a powerful point of intervention to keep this process from happening. They've actually created a drug that blocks this NMDA receptor, and it's called NMDA, or Namenda. You've heard of Namenda. That's where NMDA works, by blocking that calcium influx. So you have this feed-forward I've been talking to you about, where you have mitochondrial dysfunction from any cause, from glycation of your proteins, from being exposed to things, from maybe even an inherited issue, leads to decreased ATP production, neuronal depolarization, ultimately persistent NMDA activation by glutamate, which allows that calcium to flow in, and that ultimately feeds back and damages the mitochondria. So we have this feed-forward cycle. Mitochondrial dysfunction from any cause leads to calcium influx, which persists and perpetuates mitochondrial dysfunction. You're in the skids now. And once this happens, it's a feed forward. We've all seen patients who were getting by cognitively, and then they went off the cliff because of this feed forward activity. I don't even want to get there. I want to prevent mitochondrial dysfunction in the first place. That is the most powerful leverage point we will ever have in dealing with this situation. Mitochondrial sequestration leads to damage of calcium sequestration leads to ultimately to damage of the mitochondria. And so we take this a bit further then, leading to electron transport chain dysfunction because of this calcium influx. And interestingly enough, this pathway is dysregulated in diabetes. And this has some powerful implications. Disturbances of cytosolic calcium may represent a final common pathway for the degeneration of the brain in diabetes. All right. If anyone wants to bring me a cup of water from back in the back, I would be forever in your debt. Thank you. You know, funny you ask. So I had a group of scientists at my home a couple years ago, and my interactions with one of these individuals has really left a profound impact on me, and it was my dog Tico. And I'll tell you a little story about Tico. Tico was one day, we noticed he was losing his fur, as dogs will. And so what we did was we took him to the vet. And when the vet walked in the room, the first question she asked was, "What are you feeding Tico?" Right? My wife, I didn't really know where the food came from, so my wife answered the question, and I was just thinking, thank you, David, thinking about that question and how profound that question was. Because if you take your dog to the vet and the vet asks you that question, you're not surprised. But if you walk into the doctor's office and the first question that she asks you is, "What are you eating?" you're surprised and you might even be offended. What do I look like? Whatever. What do you mean, what am I eating? I'm here for a prescription. Damn it. But think about it. If it matters what your pet is eating, why doesn't it matter what our patients are eating? It matters a whole hell of a lot. I promise you it matters. And you know, we're not the first to say that. Let's go back to Hippocrates. Let medicine be your food and food be your medicine. Remember this one? Glucose is the preferred fuel of the brain, right? That was what we're told. I mean, the brain chooses what it prefers. It lets you know. It's like it has a menu. Protein, fat, or carbs. Today I'm in the mood for some glucose. Right. Okay. That is right there. That's what the brain prefers. You can be sure of that. Because we've always had, in the entire 2.6 million years of our existence, we've always had access to Haagen-Dazs, for sure. Who's seen this before? Ah, okay. This is where I go for information. I go to Family Feud and I said, what is the #1 source of calories in America today? Anyone? Sugar. No, I didn't see it. Let's hear another one. Somebody said, what? Show me high fructose corn syrup. Oh, please. What do I have to say, please? Oh. Okay. That's the #1 source of calories, the #1 on the list today. Yes, it's really, where did we get our start in this? And we're going to explore this in a little bit. Nothing does it like 7-Up. You got that right. I wonder how that person is now, what nursing home. But anyway, we've seen this. And, you know, we're going to talk about diabetes and glycation and becoming diabetic and what that does to your brain. But I want to talk to you for a moment about insulin resistance, because you're not diabetic yet, right? Your blood sugars are still just fine. You go to the doctor and he or she says, hey, 110, that's totally cool, you're fine. And you go out there, eat whatever you want, because everything is fine. But again, the time to fix the roof is when the sun is shining. Insulin resistance is, in and of itself, a powerful risk factor for brain degeneration. I mean, you've all seen it, but you haven't seen that little tweak. You have to stay with me on this. You got to look up. I'm not on your notes, I promise you. We had to redo everything. Insulin resistance itself in the In-Chianti study, I love the name In-Chianti, maybe later tonight, who knows, was found to be a powerful risk factor. This is way back in 2005, so we're like 8, 9 years ago. Again, what is insulin resistance? You have normal blood sugar, but your insulin levels are starting to elevate. Your pancreas is working overtime. Insulin receptors are starting to not answer the door, so your pancreas is doing its very best. So you can measure blood sugars day in and day out, and even A1C, but the trick to determining who's at risk for dementia right off the bat is to measure their fasting insulin levels, which really should be less than 2. The normal range, normal meaning within 1 standard deviation above and below the median, the normal range is what is average. And what is average these days? If you want to see average, go to an airport and sit there waiting for your flight, and you'll see people whose numbers were used to generate these numbers and a sign that says terminal. So you put those things together. Anyhow, the point is that this is called the insulin resistance syndrome, and it in and of itself is a powerful risk factor for decline on what's called the mini mental status examination. They did the MMSE on individuals, elderly folks, and look at the risk of being cognitively impaired just by being insulin resistant. They aren't even diabetic yet. So when you're pumping out insulin, you're already at risk for cognitive decline. This is a study that looks at individuals who were dementia-free and looks at them just from having an abnormal glucose tolerance test or, in fact, having diabetes. And I want you to focus on the light blue. This is all-cause dementia. This is risk for all-cause dementia just from an impaired glucose tolerance test with normal glucose, Alzheimer's and vascular. So the point is that there is this dramatic correlation not just between Alzheimer's disease and diabetes, what people now will call diabetes type 3, which is interesting, but it's all manner of glucose metabolism and insulin sensitivity that plays a major role. What we are defining or have defined as being normal is not going to cut it in terms of a brain prevention program. I'm going to ask you to consider rewriting the book about what we consider to be normal. If you're diabetic, if you're a type 2 diabetic, you double your risk for Alzheimer's. And again, type 2 diabetes is pretty much a choice, is it not? It's an induced illness. We do not have to be type 2 diabetic. Now, the relationship between diabetes and blood sugar issues and cognitive decline is thought to represent a lot of things, but I think I'd like to focus on this notion of glycation. How many are familiar with glycation of proteins? Basically, what I'm talking about here is when I say post-translational, it means the protein has already been formed, it's out and about, and it then has its terminal amino group binds to sugar, basically. When sugar binds to protein, that's not a good thing. It's called glycation. And let's have a look at that'll be on the test. And it's right in here. From here to here, you have to memorize. And NRF2 activation's over here. We'll get that in just a little bit. But let's take a look at these advanced glycosylated end products, AGEs. Who knew? The cornerstone of aging. And this is a test that looked at mini mental status evaluation, how cognitively intact you are, plotted against a type of AGE called urinary pentosidine. And this just shows that those with the highest level of glycation of proteins have dramatic decline in their mini mental status tests over a 9-year period. And you can control the glycation of your proteins based upon the foods that you choose to eat. Foods with high glycemic index, including whole grain goodness, my goodness, and dried fruits we were mentioning earlier today. But any food with a high glycemic index is worrisome in terms of not just the level of blood sugar elevation, but for the time that your blood sugar is elevated. When the glycemic index was developed at the University of Toronto, it was developed as a scale to look at the overall impact of blood sugar on human physiology. Not just how high did your blood sugar go, but what was the area under the curve between 90 and 120 minutes. Higher the curve, over that period of time, higher glycemic index. Now, how many, let me ask you, how many here actually, this is urinary pentosidine, how many measure glycation of proteins in your office practice today? No one. 2. Okay, great. All right. Here comes the punchline. How many of you have ever done a test, this is a way out there test, called hemoglobin A1C? Okay, hemoglobin A1C is glycated hemoglobin, isn't it? Hemoglobin is the protein, glycated hemoglobin, that's A1C. So you are already measuring glycation of proteins, this powerful process that leads to upregulation of inflammation, inflammatory mediators, and free radical mediated stress as much as 50-fold. So you've got this data in your hands that is powerful, and its implications in terms of the brain are absolutely profound. Here's a plot of shrinkage of the brain against hemoglobin A1C. These individuals had their A1Cs checked, and then they correlated that with MRI oximetry studies of the size of the hippocampus. What did they find? Published in the journal Neurology. Look at these numbers. You're already in the third highest category for brain volume loss if you've got an A1C of 5.6. Now, I'm not being critical, but most people have a hemoglobin A1C around there or higher, right? And when you go to the doctor, you are told, hey, your A1C is 5.6, that's in the normal range. That's not in the normal range if it's shrinking your brain every year, is it? This is the shrinkage of brain on an annual basis based upon carrying the APOE4 allele, which you cannot control. But you can control the glycation of your hemoglobin and the rest of your proteins by reducing your carb consumption. This is powerful information. Not only is it powerful, but it's empowering. You should, when you get this, when you understand this and can give this to patients, it empowers your patients with actionable lifestyle changes that can have a huge impact on their brain function and brain size. Higher normal, I love this term, look at that, normal fasting glucose is associated with hippocampal atrophy, the PATH study. And this is a great study. This was just published last year. Healthy cognitive adults looked at their baseline blood sugar levels and measured the size of their hippocampus. And here's what they did. They actually brought these people back in 4 years and looked at the shrinkage of their brain's memory center, their hippocampus. Right? They come in, here's your fasting blood sugar, we're going to measure hippocampus, and I want you to come back 4 years later, and if you remember, if they did, that's an interesting variable. I wonder if they put that into the study. Anyhow, and this is their fasting glucose in millimoles per liter. I did the math for you because we don't know millimoles per liter. I got it into milligrams per deciliter, so we're all familiar with that. And look at the shrinkage that's already happening at blood sugars of 90, 85. We're already shrinking. Look at this. So this normal of blood sugar being, oh, 108 is fine, that's not what the science is telling us. The science is not supportive of the notion that a blood sugar of 180, you're not diabetic till you're 126 blood sugar, right? That's the cutoff for being told you're diabetic. So by that logic, 125 is totally cool. I mean, I'm not diabetic. My doctor said Mylanta, or whatever they say, your doctor. But the point is, this is not a binary sort of paradigm, is it? This is a paradigm that looks at not what is common, but what does the science support as being the best? What is optimal? What do you want to learn at an anti-aging conference? Not what is common, but what is optimal. Plasma glucose were found to be significantly associated with the rate at which your brain's memory center is going to shrink. And that this accounts for 6 to 10% in volume change after you adjust for age, sex, body mass, etc. Glucose levels and risk of dementia. I do not have this. This was published last week, and I submitted these slides like 2 months ago. What can I say? New England Journal of Medicine, okay? You can get this. This is a huge study, 2,000 participants who don't have dementia. They're elderly, they're followed for about 7 years, and they get a baseline glucose, and then every 2 years they undergo cognitive assessment. And what happens? This is their rate of cognitive decline, their rate of becoming demented based upon their blood sugars. Now, they arbitrarily chose 100 as being unity for risk. I'm not sure that's fair, but that's because it correlates to 100 milligrams per deciliter of, which is considered midline of normal. But look at this. Look at the rate of increased rate of dementia. And these are blood sugars that everybody comes to your office with and their doctor says are perfectly fine. That's not up to the current level of science. That's not, as of 2 weeks ago, published in the journal, New England Journal of Medicine. Now, you can argue the point, but I would say that the New England Journal of Medicine is probably one of the most well-respected journals on the planet as it deals with medicine. Increased risk associated with higher glucose levels, even at the lowest end of the glucose spectrum, among people who never received a diagnosis of diabetes. In conclusion, show evidence that higher glucose levels are associated with increased risk of dementia. This is powerful stuff and a bit scary. This came to me. I live in Southwest Florida. I loved the cover not for any reason that you might think, but just because it says, "How can I know if I have Alzheimer's disease?" And sugar, a healthier choice. Well, if you're eating sugar, the healthier choice, you're not going to know. I can promise you. Higher serum glucose levels are associated with cerebral hypometabolism in Alzheimer's regions. What this study did was actually very cool. There are certain areas of the brain that degenerate primarily at first when you get Alzheimer's. And this is a study that looked at regional cerebral blood glucose metabolism in those Alzheimer's area and compared how functional these areas were in comparison to blood sugar. And so they had 120, these cognitively normal adults fasting sugar. That's us. This is us now. And they did this PET scan to look at regional cerebral metabolic rate for glucose in the Alzheimer's related search areas, those areas that are going to go first. So here's what happened. Here are the scans. This is this regional cerebral metabolism of glucose studies in these various areas that are correlated with areas of hypofunction as you develop Alzheimer's. And let's just see what I can do here. Let's flip that to the left, make that our y-axis. On the x-axis, we'll put serum glucose, and let's see how it looks. Again, the higher the level of the fasting blood sugar, the more compromised is the metabolism in those areas of the brain. Evidence between the relationship of fasting glucose and the predisposition for Alzheimer's disease. It suggests that in cognitively normal adults, that's us, without a history of diabetes, higher serum glucose levels may be a risk for Alzheimer's unrelated to carrying the APOE4 gene. Now, what are these AGEs that we're talking about, these advanced glycosylated end products? Again, the binding of sugar to protein is a very, very powerful event in the degeneration of your entire body. It's the cornerstone of anti-aging medicine. And how incredible it is that the acronym is AGE. When you focus on reducing AGEs, you have a leg up as an anti-aging program. I'm going to be 75 years old. And I tell that to my patients, anti-aging medicine. I don't necessarily tell them that 17 years from now, but I am going to be 75 years old. So, Ellie, we did try the joke, and it looks like it's a no-go. I was going to use that one on the public PBS special, and somebody said maybe you shouldn't use it. I think we're going to leave that one out. Do you think it was good or no? All right, never mind. Anyhow. But these AGEs are not just a marker of aging of our tissues. They're powerful upregulators of cytokine activity and free radical production. The binding of sugar to your proteins turns on inflammation and oxidative stress, the two pivot points that we talked about a while ago, that lead to mitochondrial failure, that leads to neuronal apoptosis and dropout of cells in your brain. Reduce the formation of these AGEs, reduce the glycation of your proteins by reducing your sugar, reduces inflammation and reduces oxidative stress. This is how we now understand that these so-called unknown factors are not so unknown after all. AGEs, advanced glycosylated end products, are powerful activators of the microglia, leading to inflammation and oxidative stress, which then ultimately culminates here where we get pills. We've got to start with the ice cream. We've got to start with the diet. Now, this is a protein called beta amyloid, which has been the focus of extensive research in Alzheimer's. I mean, Alzheimer's is caused by the accumulation of beta amyloid in the brain. End of story. And that's why all these new pharmaceutical schemes to get rid of beta amyloid have done a great job at actually making people worse. A month ago in the New England Journal of Medicine was published an interesting report, yet again another failure of anti-amyloid therapy, and I wrote a Huffington Post about this, showing that when you got rid of the beta amyloid, actually the patients became more demented more quickly. Another discussion we could have is the role that beta amyloid plays as an antimicrobial peptide, and very well could represent its presence as a response to something like herpes simplex virus type 1 or chlamydia. It's the brain's attempt to protect itself. It's not the enemy. But when you accumulate this protein in the brain, and there's more of this protein in the brain, it, like other proteins, can become glycated. You see great accumulation here of beta amyloid in vivo in the Alzheimer's patient's brain versus control. This is the so-called Pittsburgh compound. But again, beta amyloid can become glycated, and when it becomes glycated, it generates reactive oxygen species and activates NF-kappa B. That's a cellular signaling system to turn on the production of inflammatory mediators by activating microglia, who make these inflammatory mediators, and enhances the production of some very powerful radicals in the brain when you glycate beta amyloid and other proteins. So what can we do from a nutritional perspective? Here are some things that are very important that serve as anti-glycating therapies. And the most important nutritional supplement is the very last one on the list. Low carbohydrate diet. Far more important than anything you can give to a patient. Get the carbs out of the diet. Now, when you read Wheat Belly, you are taken by this powerful message, and when Dr. Fasano lectures, you have this powerful message about the various parts of the immune system, the innate immune system, the toll-like receptors, HLA-determined receptor sensitivity, etc. And it's about reaction to protein, basically. But the other important message that Dr. Davis made in his book is that, like it or not, these wheat products, aside from their antigenicity and their role in the immune system, are powerful carbs. Wheat products represent 20% of the calories consumed on the planet, and pretty much those are carb calories. So whether it's wheat flour or rice flour or any type of flour that you can make, whether or not, even beyond the gluten part of the story, flour is a wonderful way to increase the surface area and break down carbohydrates and make it available to spike your blood sugar. So resveratrol happens to be a powerful anti-glycating agent, and I just think if you have, well, this is an interesting study. This is a look at, before I get to resveratrol, you know, everybody's focused on the damaging effects of, dare I say, cholesterol. What a horrible thing cholesterol is. We've got to do everything, especially bad cholesterol. If you're religious, you would say that God created. If you're not religious, you would say we evolved to have LDL, right? Whatever. But why call it bad? I mean, it's like saying your tonsils are bad, let's take them out. Now, no, you know, can you imagine taking someone's tonsils out? You know, who would do that? But the point is LDL there? Why would it be there if it's so darn bad? And cholesterol, why would it be there if it's so bad? Why would every cell in your body make this stuff if it's so bad? LDL cholesterol is not cholesterol. It's a lipoprotein. It's a protein. Low-density lipo, not cholesterol, lipoprotein. And what have we been saying about proteins? We have been saying that proteins can become glycated, and when they become glycated, that's a problem. So when we look at things like LDL, the whole number, or even the particle size, it's important to ask the question, does the oxidation of that low-density lipoprotein have a role to play? Turns out that is a powerful player in terms of it being atherogenic, whether or not it's oxidized. And this is an interesting study looking at the carotid intimal thickness of oxidized LDL and AGE, or glycated LDL, and showing that there's this powerful relationship that's very similar for AGE-modified LDL and oxidized LDL. Basically, when you glycate LDL, you oxidize it. When it's oxidized, then it becomes atherogenic. So the LDL in and of itself is not the issue. It's the oxidation of LDL, the damage to LDL, that makes the immune system say, what is this stuff? I'm going to react against it. When you look at an atheroma in a coronary artery, I'm sure Dr. Davis will tell you this, it's not that cholesterol has plugged the artery and you need to pour some Drano in there. You don't find gobs of cholesterol. You find an immune reaction, and the immune system is seeing this oxidized LDL and goes, what in the heck is this stuff? We better wall it off. How do you control the oxidation of your LDL? Well, you can take antioxidants, but the key player is that there is this correlation that's dramatic between the glycation of the LDL and being oxidized, as you see here. High levels of oxidized LDL and LDL have a major impact on progression of carotid endomal thickening in type 1 diabetes, and they help to identify patients at high risk for coronary vascular disease. I'm going to move past this. Oh, I do want to say, therefore, the pathogenic role of modified LDL should not be limited to diabetic patients, although the study was done in diabetics. It's all of us. So how can you assess, laboratory-wise, the glycation of LDL, the glycation of this protein? Does anybody here do any kind of testing in their office that looks at glycation of proteins in general? You do, actually, hemoglobin A1C. This is a direct correlation between glycated LDL and hemoglobin A1C, a perfect correlation. So when you are now looking at hemoglobin A1C, you're getting really good information about the oxidative state of that person's low-density lipoprotein. Control the oxidation of their lipoprotein by controlling glycation of proteins in general, and you have a powerful leg up in terms of atherogenesis and other degenerative conditions. I love the word therapeutical. This came out of, I think it was Scandinavian journal, but simply stated that glycated proteins produced 50-fold more radicals than non-glycated ones. Pharmacological approaches which break this vicious cycle of oxidative stress and neurodegenerative offer opportunities for the treatment of Alzheimer's, correlating glycation of proteins to Alzheimer's. These approaches include AGE inhibitors, antioxidants, anti-inflammatory substances which prevent radical production. I would say to the researchers, and I'll say to you right now, why don't we prevent the glycation of the proteins in the first place? The most effective thing to do is to tell people what to eat. If you don't eat carbs and you eat more fat, you won't glycate your proteins as much. That was demonstrated in the New England Journal of Medicine study that looked at comparison of these diets, and I don't know when exactly we'll do that. Again, the fundamental player is oxidative stress in the neurodegenerative conditions. We talked about it. It's the early event. We shouldn't be hanging our hats on the latest and greatest antioxidant that was discovered in a berry from Polynesia that's now a multi-level, and you've got to do this because if you take this drink, your children will be born without any clothes, or some crazy thing's going to happen, whatever. Prevent the oxidative damage in the first place by changing the diet. This is not our answer. This is not what we should be doing in order to control blood sugar levels. We should be making lifestyle changes. And what does the science tell us about the difference between treating people with the most commonly used prescription for diabetes versus the lifestyle changes? Now again, this is the New England Journal of Medicine, and what did they say? This is a study comparing lifestyle intervention with the use of the drug. 3,000 individuals who are non-diabetic, about 51 years old, younger than I am. They have a little elevation of their fasting blood sugar. And here's what they were given. Either metformin, 850 twice a day, pretty good slug, or 150 minutes of exercise each week. We've already done the math, divide by 7. That's really quite aggressive. And a low-calorie diet to achieve a 7% body weight loss. They follow these people for up to 3 years. This is the amount of physical activity. So it shows that both the metformin group and the placebo group really didn't do a whole heck of a lot. But the people who were told, hey, there is the possibility, we've done the IRB, and the reason you're participating because it looks like there may be some upside to doing exercise and losing weight. There's a stretch there. But nonetheless, these individuals, and we're talking about close to 3,000 people, who lost weight. Well, the lifestyle people, as you would expect, lost the most weight. But here's what's really important. Here's who got diabetes. Who got diabetes? A disease that doubles your risk for Alzheimer's. Well, the placebo group, obviously, then the metformin, but those who had the lowest risk of getting diabetes simply changed what they ate and exercised. But here's really what I find to be the more important take-home message. Again, this is the reduction in diabetes incidence, important as it is, but this is who died. That's an endpoint for you. This is the endpoint, who ended up being dead. And this is the metformin group. The placebo group, less than the intervention group, and here's the lifestyle group. A 50% reduction in getting to be dead as an endpoint by simply changing what they ate and exercising. Put that down, you fool. It's a bone of contention. Thank you very much.
You've just heard Dr. David Perlmutter discussing preventable risk factors for avoiding neurodegenerative disease, primarily dietary factors, harvesting the power of epigenetics in determining whether our brain ages successfully or not. Cell Science Systems has several assays relevant to this lecture series, the first being markers which determine genetic predisposition for celiac disease. This includes the HLA DQ2 and DQ8 genes. Also available are various antibody markers such as tissue transglutaminase, TTG, and deaminated gliadin peptide, DGP. As well, ASCA, anti-Saccharomyces cerevisiae antibody, found primarily in inflammatory bowel disease patients with Crohn's disease. Additionally, cellular analysis for gluten and other food sensitivities using the ALCAT methodology is available. These assays are available to providers in various single and multiple assay configurations. To inquire for additional literature or research, you can contact the lab at info@alcat.com.